Areas of shaded region. I want to look at areas of shaded regions today. And we've done a little bit of this before. We've worked with shaded regions when we had like a triangle inside of a square or a trapezoid with a kite or things like that. Today we're just going to have them with circles and things. And yes, it starts out pretty quick and basic. And then we slowly throw the curveball at you. Because why not? Jinx, you owe me a Coke.
Probably can't choke on it. You choke on like everything. Like carrots, apples, water. You're on spit too. That wasn't fun.
Alright, cool. So when you're doing stuff like this, it's basically identifying the two or more shapes that you have to worry about. In this case, it's pretty easy. It's two circles. You have a large circle and a smaller circle cut out of it. It's the donut problem. Okay. So what you have then is the area of the large circle. Subtract the area of the small circle. Now, I'm going to do this a couple of ways with you guys today. I'm going to leave things in terms of exact answers as well as remind you how you get decimal equivalencies. Because I might ask for either. So this is tough. How do you find the area of a circle? No, it's round.
What? What did you just say?
No, it's round.
Pi r squared.
No, it's round.
I'm so confused.
What?
Pi r round.
Correct!
What? It's not square. Pi r round.
I'm joking with you guys. Jeez.
I'm so confused.
Just nod and smile and I'll go on my merry way. Don't humor me.
You always humor you.
I know. What's the radius of the large circle? 4. So what's 4 squared?
16.
To that we have to subtract the small circle. The small circle has a radius of 2, which gives it an area of
Square.
4
Pi.
pi. Thank you. Now, when you are combining like terms, you can combine like terms that have pi in them because you treat the pi as like you would any other variable. So 16 pi subtract 4 pi leaves you how many pi's?
12.
12 of them. And obviously units. Now this is a pretty straightforward one. If you threw it on the calculator, it will just give you 12 pi as your answer. If you by chance it did ask you to round to the nearest hundredth, you would just press that double arrow button and then it would pop. It would pop out the answer for you in decimal form, approximately 37.77 what?
Oh, it's 37.699, so I just rounded.
Okay, yes, that's right. And that's what you would do. Okay? Like I said, not a lot of crazy here. Yes.
We're finding the area of the circle.
Yeah, well, they're both circles, yes.
The pi one?
They both have pi in them, yes. The shaded, yes. We're finding the area of the shaded. Usually it's what we're always worried about, a shaded region. We don't normally worry about the unshaded.
What about the other
June, I need an escort to take me out of class. Go with him.
I'm looking for something to do.
Shouldn't are you mad at me this time?
Are you going to go?
She's so
She's
so
very bad.
she's so mean.
She got it? All
All right, let's go again.
called tuna again?
How about squares?
The shaded portion inside the square, correct. Now, this one you had a square with a circle cut out of it. So what would the large shape be? A square. The small shape is the circle. I know. Let's pace ourselves. I know. I'm sorry. I don't mean to push you guys too much here. So we have to do the area of a square, subtract the area of a circle. Well, what's the area of a square? Length times what? Height, side squared.
Yeah.
So this one is 10 by 10, gives you an area of
100.
100.
Units squared. No.
Now,
Well, because of the area.
now that 10 is also represents the what of the circle? The diameter. So if the, it's a chord, yes, but it's a special chord. If the diameter is 10, what is its radius?
5 pi. Oh,
So the area of a circle then is just pi r squared. In this case, it's 5 squared, otherwise known as 25 pi. So here's an example of what you would do if it asked you for, something in exact form. 100 minus 25 pi would be an exact answer. No decimals. Don't need it. If I asked you to give it to me in terms of a rounded out answer, you would just press that in the calculator and hit enter, and it should spit out
21.460.
21.46 square centimeters. Okay. All right. So there's two versions of an answer. You can have either exact, where you have it in terms of pi, or you might have a square root in it, or you have the decimal equivalent when you press buttons and round to the nearest hundred. Basically, all these problems turn out to be just doing two areas at once. That's it. Yes, ma'am. What do you mean? We did. What's called tuna again?
I think so.
I'm very
Sometimes the square is in a circle.
So we're not gonna find the area of the square that we're shading
That's good timing, is that?
She won't come back. Was she not welcome back at Chi-Chi?
You alright, Tobe? Oh, I knew that. Now, here's where things get interesting that you have to really start paying attention to what's going on.
We have to find triangles too.
Oh, hold on. In this case here, you've got a circle and a square on the inside of it.
Right.
Okay? Correct, because they give you a diameter of 16, which makes you have a radius of 8. Okay. Oh, that's.
Why did you do that?
I was just seeing if you're paying attention. So you have the area of a circle, subtract the area of a square. The circle is the easy one to find in this case. You have a diameter of 16, which gives you a radius of 8. Now, if 8 is your radius, what's the area? Which is 64. Good. Now, the other part, you have to do a little bit of work. When you're dealing with a square and you know its hypotenuse, or diagonal, excuse me, you have to remember what that actually creates. Oops. What kind of a triangle is created? The diagonal. Our special right triangle. Which of the two special right triangles is it? Thanks, sir. Is it the 30? Oh, I didn't collect it. Add it to the homework from last night. The sheet's online. Right.
Did you see the way he ran back to the door?
No,
Oh my
I
god.
missed it because this is in my way.
That was weird.
So, is this a 30, 60, 90 or a 45, 45, 90?
36 and 90.
When you have a square, it's always going to be 45.
45.
Because it's going to be 45s because these are the same.
Yeah.
Therefore, your base angles are the same. So you have to remember how to work with a 45, 45, 90. X root what?
2.
Good.
Look at that. So smart.
So you have the special right triangle that you have to deal with here. And you know across from the, guys, you know across from the 90 is 16. Wow, I wasn't even trying to do anything there.
Does it still work? Does it work without the thing on the back?
Yeah. So that's a one-step equation that you have to solve. Remember how we did that? We just divide both sides by the square root of 2. So if you divide both sides by the square root of 2, you're going to get 8 root 2. Your calculators will simplify that radical without any problem. Well, you need to have the right calculator. So that means your side lengths of the square are both 8 root 2. So when you work with this, actually, you have to put the problem itself, the 8 root 2, in parentheses in order to square that. If you don't, it'll be wrong. Okay? Let me show you what happens. If I type in 8 root 2 and I square it, my calculator, your calculator, thinks just to square the root 2, and it'll give you 16 as your answer. But what you're trying to do is take the whole segment, 8 root 2, and square it. Because that's what that means, 8 root 2 times 8 root 2. So whenever you have a radical, and we've talked about this before, bless you, if you ever have a radical and you have to square something, throw it in parentheses, otherwise you'll be wrong. So now you have your area of your square at 128. So it's 64 pi minus 128. That square feet. That's my exact answer. If I type it into my calculator then to get a decimal equivalent, it gives me something else. 64 pi. $73.06. That's what this stuff is doing. It's a matter of just putting more than one part together, or one more piece, excuse me. One or more pieces together to figure out areas. It's not horribly difficult, but you're going to have to utilize some of the old stuff to get back and forth to it. All right? Okay. All right, let's make things more complicated then. It's more fun that way.
No, it's
It's exciting. You guys complain too much.
someone asked me what my talent was, and someone else said painting. At my work. I don't think
29 looks fun. Oh, so is 30. Oh my god. Thank you. Carry on.
well, that's a lot of circles.
How many?
4.
Are all 4 of those circles the same?
Yeah.
How do we know they're all the same?
Yes, that one.
Because they all have the same radii. All their radii are the same because they all have tick marks. Okay? Well, what's the large shape? It's a square.
Oh, yeah, it's a square.
Ah, careful. You're on the right track. You're on the right track. If there's each one had a radius of 10, this would be 10 plus 10 plus 10 plus 10, which means it would have been. So now if I look at this, we have the square. You have to subtract out how many circles? 4. And this will happen, where you'll have multiple shapes, multiple things that to put together. Okay. Well, area of a square is easy. It's just side squared. So this is 20 by 20, which gives you how much? 400. To that, we have to subtract out 4 areas of circles. Well, if you look at the diagram, the 20 represents going all the way across. That means the diameter of each circle is how much? Which means each radius is what's 5 squared? Times 4. 100. So your area would be 400, subtract 100, 5 square inches. And that would again be my exact answer. Plus 9. That's why I'm showing you guys how to do both of them. Sometimes I'll ask for it in exact form. Sometimes I'll ask for it at around the nearest 100. So you just got to read the instructions. That's all. If I get the decimal of this, what do you get? What was it?
85.84.
85, 84?
Yeah.
Wait, does everybody else get that?
I got it.
I think that's what it was last time. Okay. Again, not too crazy, not too difficult. It looked like it would be awful, but so are you, but I don't complain.
Throw it out twice.
Maybe the third time will be a charm. You're lucky I'm not United Airlines. I'm rolling. Yeah.
Oh, you're actually standing. Hey, Murphy, now if you're on United Airlines and you're not rolling, you're out.
That's true. That's true. Come on, let's load. What's that, Tope? Not really. You know? And granted, I know that you're gonna these aren't the most favorable things in the world to try to draw because
Yeah, oh crap. Turns out.
it's okay, it's okay. Now, what you're trying to do here is you're gonna find the area of both of the yellow portions of circles. Now, what I want you to think of is you basically have 2 things to worry about. You have to get the area of the outer ring, and then you'll have to subtract this inner ring. Okay? Basically what you're doing here is you'll take the area of the whole thing, and you're going to subtract out the inside. Now, the whole thing had a radius, I believe, of each. It was 8 for the whole thing, wasn't it? The whole thing had a radius of 8. So the area of the outer ring, radius of 8, would be. If the radius is 8, what's the area? Of the whole thing here would be 64. So I have a 64 pi. But then I have to subtract this portion, which was how much? It was 6. So if that radius is 6, you subtract out 36 pi, because that's 6 squared. That leaves me each of these parts were 2. So that leaves me then, by taking just the regular donut problem, that outer ring has an area of 28 pi. And now, I'm going to do the exact same thing for the inner problem. I don't need to worry about the outer ring or this ring in here. I'm going to look at this part of the circle, having a radius of 4, and I'm going to subtract out the inner circle with a radius of 2. So if I have a 4 radius, what's my area? 16 pi, good. If I have a 2 radius, what's my area? 4 pi. Which gives me this ring in the middle, an area of 12 pi. Thank you. So the areas of the yellow then, thanks, is 28 and 12, otherwise known as 28 plus 12 is 40.
He looked down at the door going like, what?
I know.
He's like, should
All
I
right.
copy that? Right.
Not terrible, is it? It looks like there's a lot going on, but you have, all you're doing is you're just basically finding an area of more than one object. And you're just adding them together. Okay. We do a lot of this style problems with bullseyes and stuff. We'll do a lot more of it coming Friday when we start doing probabilities too. Okay. Let's try a different one, man. Now, if I try a different one, I am. Okay. I am looking at now. I'm looking at a piece of macaroni, like a macaroni noodle. I'm looking at a single piece of macaroni and cheese.
Well, then you must be very sad.
What's that?
Respect that.
I'm looking at the yellow one. Yes.
Are they equal?
What? Well, it
Okay, but it says the stuff on one side.
I-
One's 180.
Okay. No, it's 180 also. Sorry. No, what they're asking for the shaded features. You're right by saying half the areas on one side, half the areas on the other side, but you got to get rid of that other half circle on the right. Okay. Anyway, so if I just do this, isn't that the same? All we're doing? If you look at it, I'm looking at two half circles. So is it half a circle, half its area? Okay. So area is pi r squared, so it's going to be a 1/2 pi r squared for the large part. Subtract out a different 1/2 pi r squared for the small part. Well, the large circle has a radius of 17 plus 17, otherwise known as
34.
34.
Gotcha.
So I have 1/2, guys, come on, 34 squared, put a pi next to it. subtract 1/2, 17 squared, and put a pi next to it. And that gives me my overall area. All we're doing here is you're looking at half the circle, okay? Okay. I don't know what you get. What do you get on this? It is.
So what you didn't do?
867 pi over 2.
867 pi over 2, otherwise known as, can you hit me a double arrow real quick, please?
1361.88.
Something squared. Okay? It's not crazy. There's not a lot of messiness here. It's just a matter of understanding what shapes are or how they're created. What's wrong?
What's the thing after the first?
This?
Yeah.
No, this was just approximately.
But it was
No, it wasn't.
Oh, yes, it was.
No.
Yeah, it was.
Get your eyes checked.
That's what she was asking. Yeah, I mean,
It doesn't.
So, yeah.
Hit the wrong button.
You look worried with me. Why didn't you?
That's enough.
It looks like a smiley face.
I'm easily amused.
Aren't we all?
Alright, this is the last one I have for you. Last one I have. It's more of an ellipse. So, yeah. The shaded white, wouldn't it just be white? More often than not, you're always going to say shaded region. The shaded region will be the darker of the two regions that you see. So I could say find the area of the non-shaded region, but in this case I'm going to say find the area of the shaded region. So what happens here is that you have to take into account something that you've done before as well. When two lines intersect, how many different angles are created? Different. Two. Sometimes it could be just one angle, it could be right angles, but more often than not you wind up with just two angles because of vertical angles. This example is showing you that you have vertical angles via the tick marks. So if you have 109 on the right, you'll have 109 on the left. What is the angle that has to be next to the 109s? 71, it's good. So that means that the angle for both both yellow spots would both have to be 71. Now if I take those two wedges, aren't those two wedges not a half a circle, but they're a sector? And that's what we talked about yesterday. Area of a sector. The portion of the circle is angle over 360 times your pi r squared. Well, I now know that I have an angle. I have 271, so 71 and 71 gets me 142, I believe.
Yes.
So I just put in 142 over 360 times 5.2 squared and slap a pi next to it. Okay? And you just put that all together in the calculator. And then I'll give you some decimal equivalent. What do you get? Oh, you got pi. You know this, right? You just got to pi.
I not bet you.
33,507 would be 3351.
Yep.
Shaded regions. Okay? Sorry to bore you. I'll work on it. I'll get that. Yeah.
It was like a lone bee, like right over here. Would you let yourself
I beg to differ on that. Hey, add this to the sheet you guys already started with your homework from last night. Yes, sir. What's that?
It would be like so. I was gonna go over there.
Do 13 through 27 on this one.
Wait, we're adding on to it, but
Yeah,
it's
just-
like it's up.
Yeah, just add to the. Just put it on that because I don't want you to do the work on here. There's no room.
Oh, okay.
Just use this as like the book page, if you will, and just add on to what you already have. Okay.
What do we do? I already forgot their numbers.
You're the only one that assigned me homework in like the last few days. So you know.
I'm sorry. Well, I didn't hear you. What?
You're the only one that assigned me homework in the last few days.
Sorry. I'll get over it.
Assigned homework, but it was like, oh yeah.
It's not a lot. It's just daily. Math, you have to do it. If you don't practice it, you won't remember it. You won't forget. You won't do well on it. So math is just practice.
Have you had Spanish with Mr. Rouse? Because he gives homework every day.